Hello there, and welcome to the Science for Sleep. Tonight we drift into the ancient and extraordinary world of geology, the deep memory of our planet written in stone. Long before stars were named or oceans had boundaries, the Earth was already alive, reshaping itself in silence. Mountains rose and crumbled, seas vanished and returned, continents wandered across glowing oceans of rock. The ground beneath you is ancient beyond imagination, and yet it is still moving, still breathing, still changing. This is the story of geology, a story of fire and water, of creation and collapse, a beauty that takes millions of years to unfold. Beneath every step, within every pebble, there are whispers of volcanoes, glaciers, and stars long gone. The surface of our planet may seem calm, but beneath it lies a vast machinery of heat and motion that never rests. If you close your eyes, you can almost feel it, the slow heartbeat of a world alive beneath stone. Earth's crust, the solid shell we live on, is thinner than you might imagine. If the planet were the size of an apple, the crust would be no thicker than the fruit's skin. It stretches only about 30 kilometers deep on average beneath land, and less than 10 beneath the sea, floating on a vast mantle of slow-moving rock that makes up most of Earth's volume and mass. The crust floats on this mantle like fragile rafts adrift on molten currents, carried and reshaped by the power of plate tectonics. Mountains, valleys, and ocean trenches are mere ripples on the surface of an enormous sphere of stone, and everything we know, every forest, every city, every ocean, exists atop this thin, shifting layer. Beneath it, rock flows like honey in a deep, timeless current. Granite, one of Earth's most common and beautiful rocks, was once molten, glowing in hidden chambers beneath the crust. Long before it hardened into the rugged stone we see today, granite was alive with heat, gathering and moving like a slow river of fire. Over millions of years, it cooled and crystallized into the familiar speckled pattern we know, forming the hearts of mountain ranges like Yosemite's cliffs and the Scottish Highlands. Each grain of quartz and feldspar once shimmered in the molten glow of the deep earth before solidifying forever. When you run your hand across a granite rock, you are touching the frozen remains of a world that once flowed, a snapshot of fire turned to stone, a message written in patience. It holds within it the calm endurance of the planet itself, a reminder that what appears solid today was once fluid, a slow miracle of transformation under unimaginable pressure and time. Deep within the mantle, carbon atoms undergo a transformation that borders on the miraculous. Crushed and heated for billions of years, carbon becomes diamond, the hardest substance known, born from chaos and pressure. Most diamonds take immense time to form, yet some are created almost instantly when the conditions are just right, in a heartbeat of geological energy. Miles beneath our feet, temperatures soar hotter than molten metal, and pressures rise beyond imagination. When volcanic eruptions occur, they sometimes carry these precious crystals upward through narrow tubes of rock called kimberlites, delivering to the surface the treasures forged in the planet's fiery heart. Every diamond, no matter how small, once existed in a world of darkness and unbearable heat, born in silence, shaped by time, and carried upward in violent bursts of creation. Each one is a story of change, of carbon becoming brilliance, of chaos becoming order, of beauty rising from pressure. The same process that shapes diamonds also sculpts the mountains above us. Mountains appear eternal, but they are alive. Deep beneath them, tectonic plates push and collide, forcing rock upward inch by inch. In the Himalayas and parts of the Andes, these collisions are still happening, lifting peaks faster than your fingernails grow. It sounds almost still to us, yet across millions of years, this slow motion carves entire continents. Wind, rain, and ice wear the peaks down grain by grain, while forces deep below build them again, a ceaseless rhythm of destruction and rebirth that has continued for hundreds of millions of years. A mountain may seem solid, but if time were sped up, you would see it breathe, swelling upward as continents collide, then slowly crumbling away. Beneath your feet, stones that once lay on the ocean floor may now rest atop mountain peaks, carried skyward by the endless shifting of plates. Earth's crust is not a still shell but a restless sea of rock. Beneath the crust lies the mantle, a region so hot that even solid stone behaves like a slow-moving liquid, flowing over eons. The continents ride atop this mantle as enormous rafts, drifting across the globe by a few centimeters each year. It seems insignificant, yet over time, these small movements reshape the world. Oceans open and close, mountains rise, deserts shift, and entire climates transform. The continents we know today are travelers, endlessly wandering. Once, long ago, they were joined together in a single supercontinent known as Pangaea, surrounded by an immense ocean. Over hundreds of millions of years, Pangaea broke apart, and the drifting continents created the world as we know it. But one day, far into the future, they will meet again, merging into another vast landmass. Our planet is alive beneath its calm surface, and we are passengers on this slow, majestic journey, carried across geological seas without ever feeling the motion. The ground beneath us is constantly being destroyed and reborn. This great cycle of renewal is called plate tectonics, the invisible force that drives continents apart, forms mountains, and renews the ocean floors. Where plates collide, mountains rise. Where they drift apart, molten rock wells upward to create new crust. Where one plate sinks beneath another, it melts back into the mantle, becoming part of the earth again. Even the ocean floor is constantly being made and remade, spreading from underwater ridges and disappearing into deep trenches over tens of millions of years. Every grain of sand, every coastline, every volcanic plain is part of this quiet planetary. Earth is the only world we know that recycles itself so completely, its skin forever shedding and remaking itself through the slow power of heat and gravity. Though we cannot feel it, the ground beneath us is in graceful motion, shaping the future with every breath of time. The Himalayas, for instance, are still growing taller each year. Around 50 million years ago, the Indian plate collided with the Eurasian plate, folding the crust upward like soft cloth. That collision continues today, pushing the mountains higher by a few millimeters each year. Their peaks may seem eternal, but they are living monuments to this slow, unending force. Wind and glaciers grind them down, while pressure below forces them up again. Every tremor, every distant earthquake, is the whisper of that colossal pressure still at work. The Himalayas are not relics of the past but living mountains, still being born before our eyes, rising as continents crash together. The same immense collision that built Mount Everest continues to reshape the land beneath millions of people. In their silent rise, these mountains remind us that Earth's power is patient and relentless, sculpting continents as easily as clay. Continents drift as slowly as your hair grows, advancing only a few centimeters each year. It may seem imperceptible, but over millions of years, that motion rearranges the entire face of the planet. The Atlantic Ocean widens each year, while the Pacific slowly shrinks. Africa drifts toward Europe, Australia edges north, and one day the continents will gather once again into a new supercontinent. This grand, slow dance connects the fossils of ancient creatures found on opposite sides of the oceans and explains why mountain ranges on separate continents share the same roots. The ground feels firm and eternal, yet it is a restless traveler on a voyage billions of years in the making. Beneath the oceans, the seafloor tells its own story. While the continents hold rocks billions of years old, the ocean floor is much younger. At mid-ocean ridges, molten rock rises from the mantle, cools, and spreads outward, forming new crust that slowly moves away like conveyor belts. As it drifts, it collects layers of sediment, shells, and the dust of ancient creatures, before eventually plunging back into the mantle at deep ocean trenches. The oldest parts of the seafloor are only about 200 million years old, a blink compared to the age of the continents. In this way, the planet's surface constantly renews itself, forever young in geological terms. Beneath the waves, vast mountain chains, rift valleys, and volcanoes form a landscape as dramatic as any on land. There are volcanoes that rise taller than Mount Everest from the ocean floor, their summits hidden beneath miles of water. Some of them erupt in silence, sending clouds of minerals and heat into the deep sea, feeding strange ecosystems that thrive in darkness. Around hydrothermal vents, life forms unlike anything else on Earth survive on chemical energy instead of sunlight, drawing nourishment from the heat of the planet's core. These ancient, alien worlds remind us that life is woven into Earth's geology, that stone and biology are not separate, but part of one great living system. Even the air we breathe is connected to the planet's restless crust. Volcanic eruptions release gases that shape the atmosphere, balancing the carbon and water cycles that sustain life. The continents themselves influence weather patterns, ocean currents, and the flow of heat around the globe. Over deep time, the slow movement of land and sea has guided the evolution of life, sculpting environments, isolating species, and joining them again. The story of geology is not just about rocks, but about the pulse of a living world. Each grain of sand once belonged to a mountain, each stone in a riverbed once rested deep within the earth, each fossil a record of a vanished ocean or forest. The planet writes its story not in words, but in layers of stone. When we read those layers, the colors, the crystals, the fossils pressed into ancient mud, we are reading the autobiography of the earth itself. It is a story written over billions of years, told in silence, yet more complete than any book. As you lie here, breathing slowly, imagine the ground beneath you shifting gently, a living raft floating over molten seas. The continents drift quietly beneath the stars, their edges meeting and parting in slow, elegant motion. Mountains breathe, oceans change shape, and time flows like magma, slow, glowing, eternal. The next time you hold a stone, remember, you are holding a piece of the planet's memory. Within it lies fire, pressure, and transformation. Within it lies the echo of the beginning of the world. And though we move through our lives in moments and days, the earth moves in eons, its heartbeat steady, its patience infinite. Tonight, as you drift towards sleep, let that patience comfort you. Let the deep, slow rhythm of the planet lull your mind. For beneath everything, beneath every city and forest, beneath every mountain and ocean, the earth continues its quiet work, turning chaos into beauty, moment by moment, stone by stone, dream by dream. The ocean floor, though it stretches endlessly beneath the waves, is surprisingly young. Along the immense mid-ocean ridges, molten rock from the mantle rises in slow, glowing rivers, cools, and hardens to form new crust that spreads outward like an ever-expanding tapestry of stone. As this new crust drifts away from the ridges, it eventually begins its long journey back toward the deep trenches where one tectonic plate slips beneath another and sinks into the mantle's fiery depths, melting once again into the Earth's interior. This endless cycle of birth and destruction means that no part of the ocean crust lasts longer than about 200 million years, a fleeting breath in the planet's vast, ancient lifetime. By contrast, the continents that rise above the sea are the long-lived survivors of geological time, floating lightly upon the planet's surface, weathering and wandering for billions of years. If you could speed up the flow of time and watch Earth's surface unfold like a living film, you would see the oceans form and vanish in rhythm, pulsing like the heartbeat of a living creature. The seafloor is not dead but alive, its hidden plains are in constant renewal, its volcanic ridges humming with the slow energy of creation. Across this undersea expanse, the crust records the planet's memory in patterns invisible to the eye but clear as script to those who can read it. Spread across the ocean basins are magnetic stripes, alternating bands of rock, each holding a frozen memory of Earth's magnetic field at the moment it was born. These stripes stretch for thousands of kilometers across the seafloor, like a barcode recording time itself. They reveal that the planet's magnetic poles have flipped again and again, with north and south trading places countless times in Earth's history. When molten rock wells up at a ridge and begins to cool, the tiny grains of iron and nickel within it align with the planet's magnetic field, just as invisible compass needles would. Once the lava solidifies, these magnetic orientations are locked in forever, preserving a momentary direction in stone. Then, millions of years later, when the magnetic field reverses, new layers form with the opposite polarity, marking the next stripe. Reading these bands, scientists can trace a timeline of magnetic reversals that stretches back tens of millions of years, a record written not in ink but in molten fire and the quiet patience of geological time. It was this discovery, these perfect, symmetrical stripes across the ocean floor, that helped confirm the theory of plate tectonics, proving that the seafloor is constantly spreading, moving outward from the ridges and sinking again into the trenches in a cycle of eternal motion. Beneath the vastness of the oceans lies not chaos but an ordered rhythm, a planet's pulse recorded in magnetic stone, guided by heat, magnetism, and the deep, slow breath of time itself. When molten rock cools, it becomes something extraordinary. Within each volcanic stone are invisible particles of metal that once floated freely in fiery liquid. As the rock solidifies, these particles align with the magnetic field of the planet, freezing in the exact orientation of Earth's magnetic poles at that instant. The result is a natural magnet, a tiny geological compass pointing forever toward an ancient north that may no longer exist. By studying these magnetic records, geologists have mapped the wandering journey of the poles across the surface of the Earth, revealing how the magnetic field drifts and flips through the ages. Every rock born from lava is a time capsule of the planet's invisible forces. Inside them, the iron atoms whisper their alignment, telling stories of ancient fields that have come and gone, of polar wanderings, and of the deep inner dynamo that powers the Earth's magnetic heart. The planet remembers magnetically, its iron soul writing history in invisible lines across the face of the world. And deep within this world of stone and heat, every volcano connects to something even greater, a hidden heart of molten fire. Far below the mountains and plains, beneath forests, deserts, and seas, lie vast magma chambers, enormous reservoirs of liquid rock that pulse like the beating organs of a living planet. These chambers are filled with molten stone, dissolved gases, and growing crystals. Over time, pressure builds as heat rises from the mantle, until the crust above can no longer contain it. Then the volcano breathes, sometimes gently, releasing plumes of smoke and rivers of glowing lava, sometimes violently, shattering mountains and darkening skies with ash. Between eruptions, the magma chambers lie in silence, slowly refilling and evolving, changing their chemistry, cooling and reheating in the deep dark. Using seismic waves, scientists can now glimpse their ghostly outlines, like doctors peering at the heartbeat of the Earth with instruments that echo through rock. These volcanic systems form an immense network beneath our feet, connecting continents and oceans in a deep subterranean rhythm of creation and renewal. Each volcano, whether silent or roaring, is part of this living chain that threads through the planet's crust, linking surface and core in an endless exchange of fire. Not all eruptions come as sudden, violent bursts. Some last far longer than human memory, continuing for hundreds of thousands of years. When immense plumes of molten rock rise from the mantle and flood the surface, they can create vast regions of basalt called flood basalts, outpourings of lava so immense they bury landscapes, reshape climates, and even alter the course of evolution itself. The Deccan Traps in India and the Siberian Traps in Russia are two such monuments to Earth's fiery past, regions where molten rivers once spread endlessly across the land, covering millions of square kilometers in black rock. During these epic events, gases filled the atmosphere, sunlight dimmed, and life on Earth trembled in the shadow of fire. Standing on those hardened lava plains today, it is almost impossible to imagine that they were once seas of molten light, stretching to every horizon. They remind us that the Earth remakes itself not only with explosions but also through patient floods of creation, spreading quietly, persistently, with a rhythm measured in millennia rather than moments. Most of the ocean floor today is covered in basalt, a dark, dense rock born from these same molten sources. If you could walk across the bottom of the sea, every step you took would fall upon basalt, a landscape of darkness, solidified fire, and ancient patience. It forms when the mantle's molten material emerges at mid-ocean ridges and cools rapidly upon contact with seawater. The result is a vast armor that wraps around the planet's underbelly, a smooth yet rugged foundation for the world's oceans. Unlike the lighter rocks that make up the continents, basalt is heavy, rich in iron and magnesium, giving it its deep color and weight. Its layers are constantly renewed as fresh lava emerges and old crust drifts away, eventually melting once more in the mantle's slow churn. Every square inch of this basaltic world has been part of the endless cycle of creation, destruction, and rebirth that defines our planet's life. Beneath the waves, these layers pile up quietly, century after century, a record of Earth's patience written in cooled magma. And within this undersea landscape, the most delicate and beautiful formations appear, pillow lavas, strange rounded shapes formed when molten rock meets the freezing embrace of seawater. When lava erupts beneath the ocean, its outer skin cools instantly, sealing in the molten heart within. As more lava pushes forward, it inflates the hardened shell into rounded balloon-like forms that stack upon one another, resembling giant pillows or clusters of bubbles. These smooth, bulbous sculptures are geological art, each one a frozen moment in the meeting of fire and water. When explorers find pillow lava high on dry land, they know that place was once submerged beneath the sea, for only the deep ocean can shape stone this way. The sight of these formations is haunting, as though the rock still remembers being fluid, as though it still holds the memory of its last flowing motion before time locked it forever in stillness. In these strange shapes, the restless energy of the earth is captured and preserved, the evidence of a world that is always creating, even in the dark. From the ocean's depths to the peaks of volcanoes, the planet is constantly sculpting itself with both fury and grace. Sometimes this artistry is swift, so swift that stone itself becomes glass. When lava cools in an instant, without time for crystals to grow, it becomes obsidian, a sleek, black volcanic glass that shines with an inner depth. Smooth and reflective, obsidian is the frozen breath of an eruption, a mirror of fire turned to stone. For thousands of years, humans have admired its sharpness and sheen, crafting it into blades, ornaments, and sacred objects. Yet behind its beauty lies violence. Obsidian forms when molten rock, still glowing and alive, meets cold air or water and solidifies almost instantly. In that moment, the fiery chaos is stopped mid-motion, transformed into perfect stillness. When broken, obsidian fractures along curved, glass-like lines called conchoidal fractures, delicate arcs that catch the light like ripples in water. Each break is a memory of the flow that once was, the path the molten rock might have taken if time had not frozen it in place. Obsidian is both fragile and eternal, a paradox born of heat and cold, violence and calm. It is a piece of fire captured forever, a reminder that even destruction can give rise to beauty. And within some rocks, trapped for millions of years, lie even more delicate treasures, tiny bubbles of air, remnants of ancient atmospheres sealed within the stone. These microscopic pockets are time capsules, preserving the composition of the air from ages long vanished. When scientists study them, they are reading the breath of prehistoric skies, discovering what Earth's atmosphere once was, and how it has changed through epochs of fire and ice. Inside those minute cavities, a whisper of ancient wind survives, a breath taken long before humans existed, before forests grew, before the continents drifted into their modern form. Each bubble is a fragile echo of time, proof that even the smallest spaces within stone can hold the vastness of Earth's history. To hold a piece of such rock is to hold the planet's memory, a fragment of air, a spark of fire, a frozen motion of the sea, all fused into one. Every layer of crust, every ripple of basalt, every pillow of lava and glass of obsidian is part of a single, continuous story, the story of a living world that endlessly transforms itself. From the silent spreading of the ocean floor to the towering rise of mountains, from the flicker of magnetic fields to the hush of ancient air sealed in stone, the earth never stops writing. It writes not in words but in patterns of magnetism and crystal, in molten flows and quiet cooling, in eruptions and erosions, in patience and pressure. And as we drift into rest, listening to the slow music of this planet's movement, we remember that we too are part of it, atoms of stone, air, and water, carried along by the same vast rhythm that shapes the continents and stirs the depths of the sea. Beneath the quiet surface, the planet breathes, and its breath is the slow pulse of eternity. By studying them, researchers can uncover the stories of Earth's ancient skies, reading each tiny bubble of trapped air as though it were a message from another age. Within those bubbles lie traces of gases that once filled the atmosphere, oxygen that sustained forests long vanished, carbon dioxide that warmed primordial climates, and the subtle fingerprints of volcanic eruptions or biological blooms that forever altered the planet's balance. Each microscopic pocket holds an echo of a vanished breath, a ghost of the air that drifted above ancient oceans and primeval lands, surrounding giant reptiles, or the earliest forms of life that ever learned to breathe. To hold such a rock is to cradle a fragment of the planet's memory, a piece of the ever-changing sky that has enveloped Earth for billions of years. It is a fragile record of our atmosphere's long story, written in silence and sealed away within stone. Beneath the vast blue oceans of today lie mountains higher than Everest, hidden from human eyes yet stretching for tens of thousands of miles across the seafloor. These immense mid-ocean ridges form a continuous chain of volcanic peaks that encircle the planet like a stitched seam, rising higher from their base to their crest than the world's tallest mountain does above sea level. Shrouded in total darkness and subjected to immense pressure, these submarine giants are among the most active regions on Earth. Lava continuously seeps from cracks and fissures, hardening into new crust and building peaks that grow, shift, and collapse over ages. The tallest of these hidden volcanoes, such as Mauna Kea and Mauna Loa, rise from the ocean floor with such magnitude that when measured from their base, they surpass even the mighty Himalayas. Down in those silent kingdoms of darkness, the planet's pulse beats quietly, unseen yet ceaseless, sculpting the world's surface in secret. Far deeper still lies the planet's greatest abyss, the Mariana Trench, an immense gash in the Pacific seafloor nearly 7 miles deep. It is a place so profound that if Mount Everest were dropped into it, the peak would still be buried beneath more than a mile of ocean water. The trench's lowest known point, the Challenger Deep, reaches nearly 11 kilometers below the surface, where the pressure is so immense it could crush steel and silence all but the hardiest forms of life. Yet, even there, life endures. Tiny organisms glow softly in the blackness, feeding on mineral-rich sediments and living off the chemical heat from Earth's interior. The trench marks one of the planet's most powerful engines of renewal, a subduction zone where one tectonic plate dives beneath another and sinks slowly into the mantle, melting and recycling back into the planet's fiery heart. It is a reminder that the world we see is only a small part of what exists, that beneath the calm blue of the sea lies a vast and restless underworld where creation and destruction never cease. Even when the ground beneath our feet feels utterly still, the earth hums with an invisible rhythm. Thousands of tiny earthquakes, microquakes too faint for humans to sense, ripple through the crust every single day. These subtle tremors are the quiet murmurs of a planet always adjusting, always breathing. With sensitive instruments, scientists can detect these whispers, mapping the hidden faults, magma flows, and shifting plates that continuously reshape our world. The planet is never truly silent. It vibrates with a soft, ceaseless energy that tells the story of its inner motion. Beneath every mountain, forest, and sea, the ground moves in ways we cannot see, slowly stretching, cracking, and settling in patient, rhythmic motion. The stillness of the world is an illusion, a surface calm masking the restless machinery of the deep earth. Occasionally, however, that hidden energy bursts into sudden force, powerful enough to alter the shape of the land itself. During great earthquakes, rivers can reverse their flow, defying gravity for moments that seem impossible. When the ground tilts or shifts abruptly, the landscape itself may be lifted or dropped, forcing water to surge backward. Such events have been recorded throughout history, including during the New Madrid earthquakes of the early 19th century, when parts of the Mississippi River briefly flowed upstream, as if time itself had reversed. These moments reveal the astonishing strength of the planet's inner forces, energies capable of reshaping entire regions in seconds, proving that even the most ancient and constant features of nature can be transformed by the deep movement of the Earth. Yet not all tectonic motion comes with drama or destruction. Some sections of the planet's great faults glide silently, slipping so slowly that no shaking is ever felt. This phenomenon, called fault creep, is the quietest expression of tectonic power. Along certain fault lines, the crust slides past itself in near-perfect balance, moving only a few millimeters each year. These slow movements relieve stress in steady, peaceful increments, preventing larger quakes in those areas but sometimes transferring strain to others nearby. Scientists studying these creeping faults have found them in places like California and Turkey, where the Earth moves gently, whispering its adjustments over centuries instead of seconds. It is part of a delicate balance between friction, pressure, and release, a geological dance that has shaped continents for eons. Beneath our feet, the world is always in motion, shifting grain by grain in an endless act of balance. Deep within that living planet lies its beating heart, the core, a sphere of molten and solid metal that burns with unimaginable heat. Temperatures at Earth's center exceed 9,000 degrees Fahrenheit, hotter even than the surface of the Sun. This immense heat comes from two ancient sources: the leftover energy from the planet's violent birth and the slow, steady decay of radioactive elements within. Though we can never see it directly, this inner furnace drives everything from volcanic eruptions to the magnetic field that shields our world from cosmic radiation. The outer core churns like a vast ocean of liquid iron, moving in swirling currents that generate Earth's magnetism, while the inner core, a solid ball of iron, rotates slightly faster than the planet above it. This deep dynamo sends invisible lines of force stretching into space, forming a protective magnetic bubble that makes life possible. Without it, solar winds would strip away our atmosphere, and Earth would be bare and lifeless like Mars. The core's motion is the unseen engine of our world, its heat and rotation giving rise to the magnetic field, to volcanoes, to earthquakes, to the planet's living breath itself. And deep above this heart, within the rocky mantle, lies a discovery almost as astonishing: a hidden ocean locked within the planet's stones. Scientists have found minerals deep within the mantle that contain vast amounts of water, bound within their crystal structures rather than flowing freely. There may be enough water trapped there to fill the world's oceans several times over. This ancient, secret sea cycles through the planet, carried down into the deep by subducting tectonic plates and returned to the surface through volcanic eruptions and rising plumes of molten rock. Though invisible, this process may explain why Earth has oceans at all, how water has persisted for billions of years through endless cycles of creation and destruction. Even in the deepest stone, water endures, waiting patiently through ages of darkness to return once more to the light of the surface world. Beneath deserts and mountains, in caverns untouched by sunlight, the Earth also reveals its gentler wonders. Deep in northern Mexico, hidden beneath layers of rock and heat, lies one of the most breathtaking natural marvels ever discovered: the Cave of the Crystals. Inside this underground cathedral, translucent blades of gypsum stretch more than 30 feet long, shimmering in the dim light like frozen moonbeams. Each enormous crystal took hundreds of thousands of years to grow, nourished by mineral-rich water heated by volcanic energy. When the water eventually drained away, these gigantic structures were left behind, gleaming in the humid air, perfect and still. Entering the cave is like stepping into another world, a place where time moves differently, where the slow, patient rhythm of nature reveals its quiet art. The crystals formed only because the conditions were perfectly balanced, just the right temperature, just the right chemistry, and eons of undisturbed calm. In their radiant symmetry, they show that even the hardest materials on Earth are capable of growth and transformation, given enough patience. They are monuments to stillness, proof that beauty can form not from movement, but from the unwavering peace of time. Each shimmering blade of gypsum is a frozen moment in the planet's creative process, a memory of the hot, mineral-rich waters that once filled that space, shaping perfection molecule by molecule. These crystals, like the bubbles of ancient air or the rocks of the ocean floor, remind us that every part of Earth, every hidden cave, every shifting plate, every drop of molten stone, plays its part in the grand story of a living planet. From the depths of the Mariana Trench to the blazing heat of the core, from the silent creep of faults to the soft hum of microquakes, the Earth is never still. It moves, breathes, and transforms, cycling through destruction and renewal in an endless rhythm older than life itself. Each grain of sand, each mountain peak, each crystal and volcanic plume carries a piece of that rhythm, a note in the planet's slow, powerful song. We are born of that same motion, the minerals in our bones, the oxygen in our lungs, the water in our veins, all once part of that deep and ancient circulation of matter and energy. When we listen to the quiet hum of the world, to the wind in the trees or the distant rumble beneath our feet, we are hearing the echoes of that eternal cycle. The Earth does not sleep, but it dreams in stone and fire, in water and air, in light and darkness. To close your eyes and imagine its depths is to travel through time, to feel the weight of pressure at the bottom of the trench, the gentle pull of magnetic forces within iron, the heat of the core, and the stillness of crystals glowing in subterranean calm. Beneath the calm surface of the world, there lies an infinite, unseen motion, a breathing planet, alive in every atom, patient and powerful beyond imagining. It turns endlessly, reshaping itself and everything upon it, and in that motion lies the quiet heart of existence itself. Deep beneath the surface of the earth, hidden wonders reveal the slow and patient artistry of nature, a world sculpted not by hands, but by time, pressure, and the ceaseless rhythm of elemental change. In 2000, miners uncovered one of these masterpieces, a cavern whose walls shimmer with immense gypsum crystals so vast they resemble pillars of light. Some weigh dozens of tons and stretch across the chamber like colossal beams of glass. These luminous formations grew within the warmth of mineral-rich groundwater that remained undisturbed for hundreds of thousands of years, each molecule aligning in quiet precision until the perfect structures emerged. When the cave was finally drained, their growth ceased forever, preserving a moment in geological time. The air inside is so hot and thick that no one can linger for long, yet those who have stepped into this radiant cathedral describe it as walking through a dream, an untouched gallery where time, water, and the chemistry of the earth have worked in secret harmony. Elsewhere, beneath vast layers of rock, salt domes rise like slow explosions frozen in motion. Formed from ancient seas that evaporated long ago, these immense salt deposits were buried under heavier layers of sediment. Over millions of years, the immense pressure forced the salt to flow upward, bending and fracturing the rock above. Though solid, salt behaves like a slow, viscous fluid under such pressure, rising through the earth to form dome-like structures miles high. These domes often trap oil and gas, creating natural reservoirs that have shaped economies and civilizations. From above, they appear as gentle hills, but deep below, they are powerful columns of motion, living proof that even the ground beneath our feet is never still, that the earth itself breathes in movements too slow for us to see. Petrified Wood offers another glimpse of this slow transformation. What seems like a stone tree is in fact the ghost of one, preserved molecule by molecule as minerals seeped into its cells. When buried under volcanic ash or sediment, groundwater carrying silica infiltrated the wood, replacing each organic structure with quartz while maintaining its shape in exquisite detail. Over millennia, the tree turned to stone, its rings, knots, and textures frozen forever in shimmering crystal. Trace minerals painted these fossils in shades of red, yellow, and green, turning decay into beauty. To hold a piece of petrified wood is to cradle a memory made solid, a living thing transformed by the patience of time, proof that nothing truly vanishes in nature, it merely changes its form. From these fossilized forests came another transformation, the birth of coal. Long before humans existed, lush tropical swamps covered ancient continents. As these vast forests died, their trunks and leaves sank into oxygen-poor waters where decay slowed almost to a halt. Over eons, layer upon layer of this organic matter accumulated, compressed under its own weight and the pressure of sediment above. The slow alchemy of heat and time turned it into coal, a dense black rock of concentrated carbon. Inside every lump lies the ancient energy of sunlight once captured by plants from prehistoric skies. When burned, coal releases that ancient light once again, energy resurrected from a vanished world. It is a story of transformation, of life turned to stone and sunlight to fuel, a testament to Earth's endless cycle of renewal. Even deeper in time, oil began its story in the primordial seas where microscopic plankton drifted under the sun's early rays. When these tiny creatures died, their remains sank to the ocean floor, forming layers of organic-rich mud. Over millions of years, the immense weight of the sea and the heat from within the earth pressed and transformed this matter into hydrocarbons, the liquid energy that fuels our modern civilization. Each drop of oil was once a sunlit cell in the ocean's earliest life, transformed and stored beneath stone until humanity learned to draw it out. Oil, coal, and gas are not merely resources. They are condensed time, the biochemical echoes of vanished worlds. Yet even the humblest thing, a grain of sand, carries a story just as grand. Each tiny fragment once belonged to a towering mountain, a rock face, or a volcanic plain. Over millennia, wind, water, and ice ground those mighty forms into their smallest pieces, carrying them through rivers, across deserts, and along coasts. A single grain may have tumbled through glaciers, drifted across oceans, and been reborn countless times in new stones and sediments. Under a microscope, sand reveals its past. Some grains glitter with quartz that once formed the heart of ancient continents, while others are shards of volcanic glass from eruptions long forgotten. Every handful of sand is a library of time, a collection of stories that speak of fire, erosion, and rebirth. In certain rare deserts, the sand itself can sing. When dunes shift under the dry wind, the countless grains slide and collide in harmony, producing a deep, resonant hum that can last for minutes, a haunting, otherworldly tone like the voice of the earth itself. Found in Morocco, Chile, and the Arabian Peninsula, these singing dunes create notes as low as thunder or as melodic as a cello. Ancient peoples believed the sounds were messages from desert spirits, but science reveals they are the result of perfect uniformity, grains so evenly sized and dry that they vibrate together like the strings of a vast natural instrument. The desert, under the sun's gaze, becomes a symphony of friction and physics, playing a music as ancient as the wind. On distant shores, the story of sand continues, for not all beaches are born of stone. Some are made from life itself. Along certain coasts, the sand is composed entirely of tiny shells, the broken remnants of marine creatures ground by the tides into soft, powdery fragments. These biological sands gleam white beneath the sun, blush pink from coral, or glow golden from microscopic algae. To walk these beaches is to tread upon the memory of the sea, each grain a fragment of a life that once floated in the waves. The world's most famous white beaches, from the Bahamas to the Maldives, are not just scenic paradises but vast memorials to the ocean's ancient creativity. Yet Earth's shores come in many colors: black, green, red, and pink, each a reflection of the planet's boundless diversity. Black sands, born of volcanic fire, form where molten lava meets the ocean and shatters into glassy shards. Green sands sparkle with crystals of olivine, carried up from the deep mantle. Pink sands glow from crushed coral and shell, while red sands bear the stain of oxidized iron rock. Every color tells of fire, water, and time, of the forces that shape our world from within. To walk across these multicolored shores is to step across Earth's palette itself, where every grain is a pigment of geological art. Above them all, glaciers carve the planet like slow-moving rivers of stone. Though they appear still, they flow with the weight of mountains, grinding valleys and sculpting continents as they advance and retreat through the ages. In their frozen silence lies another story, one of persistence, power, and transformation, echoing the same eternal truth written in every crystal, grain, and fossil, that the earth is alive, always in motion, shaping and reshaping itself through time immeasurable. Glaciers are among Earth's most powerful yet patient sculptors, rivers of ice that flow with immense force and transform the landscapes they touch. Formed from centuries of accumulated snow, compressed under its own weight into dense ice, these vast frozen masses slowly creep downhill, carving mountains and valleys, reshaping entire continents in silence. As they move, they grind against stone, polishing rocks to a gleaming smoothness and carrying with them debris, gravel, and boulders for miles. When the glaciers retreat, they leave behind deep U-shaped valleys, moraines of scattered stone, and lakes that glisten where ice once flowed. From the granite domes of Yosemite to the majestic fjords of Norway, their fingerprints are etched across the world, visible reminders of the planet's capacity for transformation. Even now, in our warming age, glaciers continue their ancient work, grinding rock into the fine dust that drifts upon the wind, a slow, icy breath of the Earth's enduring rhythm. They are living monuments to patience, artists of temperature and time, shaping the land grain by grain in silence. Some glaciers move so slowly that their progress can only be measured over years, yet others, rare and restless, surge forward fast enough to be seen within a single day. In Greenland and Alaska, vast rivers of ice have been observed advancing by meters in mere hours, their fractured surfaces creaking and cracking as they slide forward with unstoppable momentum. This phenomenon occurs when meltwater seeps beneath the ice, reducing friction and allowing the glacier to glide swiftly over bedrock. Watching this frozen flow is like seeing time itself speed up, solid ice behaving like living stone, flowing, shifting, and groaning under its immense weight. Though we think of ice as rigid and still, under pressure it moves with surprising grace. Deep beneath the surface, where the temperature hovers just below freezing and the weight above is enormous, ice begins to deform, its crystals bending and slipping past one another like honey poured in slow motion. Over thousands of years, this movement sculpts valleys, shaves mountains, and rearranges continents. Even rock, given enough pressure and time, can flow in the same way, creeping, folding, and reshaping under forces too gradual for the eye to see. In laboratories, when ice or rock is subjected to pressure and heat, it behaves not as a solid or a liquid, but as something in between, a material that remembers movement even as it holds form. This truth, that strength and softness coexist in nature, mirrors the balance of the planet itself, where the greatest transformations come not from sudden violence, but from persistence, from the patient motion of matter under the eternal weight of time. The Earth records its memories not only in mountains and glaciers but in the smallest and most delicate traces. On slabs of ancient rocks, scientists have discovered the fossilized impressions of raindrops that fell hundreds of millions of years ago. Each tiny crater preserves a moment from a vanished world, a storm that passed over mud flats before any human eyes could see it, droplets scattering across a landscape of primitive plants and strange early life. Within seconds, new sediment buried those marks, sealing them in darkness. When uncovered today, they reveal the soft rhythm of rainfall long forgotten, the pulse of weather from a world that has turned to stone. These fossils remind us that even the briefest moment, the fall of a raindrop, the ripple of a breeze, can endure forever when preserved by chance. Some fossils hold even greater wonders, capturing not only the bones and shells of ancient creatures but the traces of skin, feathers, and color. For centuries, scientists believed only the hardest parts of life could turn to stone, but recent discoveries have revealed soft tissues, even microscopic pigment cells that show what color dinosaurs once were. These miracles of preservation occur when mineral-rich water flows through remains before decay begins, replacing fragile organic matter molecule by molecule with stone. The result is a perfect sculpture of life, a being frozen mid-motion, its details immortalized in the chemistry of the earth. Some fossils preserve the very structures that once helped creatures breathe, move, or shine under the ancient sun. Holding such a fossil is like touching the echo of a heartbeat from millions of years ago, a bridge across time connecting our living present with the vanished light of prehistoric days. Yet the story of life stretches even further back, beyond animals, beyond plants, to the first architects of the living earth, the microbial mats known as stromatolites. Long before any complex organism evolved, tiny colonies of bacteria in shallow seas began to build layered mounds by trapping sediment and reaching upward towards sunlight. These structures, some more than 3.5 billion years old, are among the oldest evidence of life on the planet. Even today, stromatolites survive in remote waters like Shark Bay in Australia, continuing the same slow, rhythmic growth that began when the planet was young. To look at one is to peer directly into life's first breath, to witness the ancient patience that turned light and water into the foundation of everything that followed. Earth's deep past was not always warm or welcoming. About 700 million years ago, the planet entered one of its most extreme transformations, an event known as Snowball Earth. Ice covered nearly the entire globe, stretching from poles to equator. Oceans froze over, sunlight reflected away from the surface, and the world became a gleaming sphere of silence and frost. For millions of years, the Earth was locked in deep freeze, its seas buried under miles of ice. Yet life endured, clinging to volcanic vents and hidden pockets of liquid water beneath the frozen crust. Deep beneath that silent surface, volcanoes continued to erupt, releasing carbon dioxide into the atmosphere. With the ocean sealed, this gas could not dissolve, so it built up over eons, slowly trapping more and more heat. When the ice finally began to melt, the process accelerated rapidly. Dark rock absorbed sunlight, glaciers retreated, and the frozen world thawed into warmth. Oceans burst free, rivers carved new valleys, and the planet was reborn in a cataclysm of renewal. This thaw may have sparked one of the greatest events in biological history, the rise of complex life. From the brink of frozen extinction, Earth emerged into a new age of diversity and energy. Volcanoes, the same fiery engines that once slept beneath the ice, became the saviors of life, their endless persistence reigniting the planet's cycle of creation. In this story lies a truth as profound as any carved by glaciers, that destruction and renewal are not opposites. but partners in Earth's long journey. Even the air we breathe owes its existence to such transformations. Billions of years ago, before plants and animals, ancient microbes living in shallow seas began to use sunlight to split water molecules, releasing oxygen as a byproduct. Over time, this invisible waste changed everything. At first, the oxygen reacted with dissolved iron in the oceans, forming vast layers of rust-colored stone that still lie buried today. Only when the oceans were saturated did the gas begin to fill the atmosphere, turning it from a suffocating mix of methane and carbon dioxide into the life-giving air we now depend upon. The world we live on is in a constant state of transformation, shaped by forces so vast and slow that their movements escape our everyday senses. Long before our planet turned blue and green, before forests and rivers and clouds filled the sky, the Earth was a restless sphere of fire and stone. Over billions of years, it has changed beyond recognition, oceans appearing and vanishing, mountains rising and eroding to dust, continents drifting together and tearing apart again in an endless rhythm of creation and destruction. The story of this planet is written not in ink, but in the language of rock, ice, and time. Those ancient microbes that once filled the early seas with their breath are the hidden authors of everything alive today. Through photosynthesis, they transformed a toxic, barren world into one capable of sustaining forests, coral reefs, and the vast diversity of life that surrounds us. The air we breathe is their legacy. Iron formations buried deep in the earth mark the moment the planet began to breathe, when oxygen first appeared in the atmosphere. These shimmering layers of red and gray stone, banded iron formations, are the fossilized record of a turning point in planetary history. As the first photosynthetic microbes released oxygen, it reacted with iron dissolved in the oceans, creating rust-like minerals that settled to the seafloor and hardened over eons. Each layer in those rocks is a silent record of the planet's awakening, a sign that chemistry had learned to give birth to life. Today, we mine those same ancient formations for iron, shaping our modern world with the remnants of microscopic life that changed the planet forever. But before oxygen filled the air, the oceans themselves looked alien. They shimmered not with blue but with purples and reds, colored by bacteria that used sulfur instead of oxygen to capture sunlight. Under an orange sky, the seas glowed like liquid amethyst, their strange hues a reflection of the chemical chaos of early life. Over time, as oxygen-producing microbes multiplied, these purple seas faded to the blue we know, signaling one of the greatest shifts in Earth's history. The transformation of the atmosphere changed everything, from the chemistry of rocks to the evolution of life. For a time, though, our planet glowed in surreal colors, a reminder that life's earliest experiments with light painted the world in shades beyond our imagination. While the chemistry of life evolved, the surface of the planet was in constant motion. Entire mountain ranges rose and vanished without a trace. What we now see as solid and eternal, the continents, the peaks, the valleys, are temporary sculptures in a ceaseless geological ballet. Wind, rain, and gravity work silently, wearing down even the tallest mountains grain by grain. The roots of ancient ranges sometimes survive, buried deep within the crust as crystalline rock, while the rest is ground to sediment and carried away by rivers to the sea. Over millions of years, erosion erases mountains as easily as waves smooth a stone. Every plain and valley we walk upon was once the summit of a vanished range. The earth is a master sculptor, reshaping itself with patience and precision, always rebuilding, always renewing. The continents themselves are travelers. Driven by the heat within the planet's mantle, they drift like slow-moving rafts upon molten stone. Over billions of years, they have collided and broken apart in a repeating cycle known as the supercontinent cycle. When they collide, mountains rise. When they separate, new oceans form. Each collision and breakup leaves scars in the crust. Matching fossils and rock formations found on opposite sides of oceans are silent proof that the ground beneath our feet has traveled vast distances. At least 6 supercontinents have existed before the world we know today. Names like Nuna, Columbia, Rodinia, Pannotia, and Gondwana belong to lost worlds that once held their own climates, mountains, and seas. Their assembly and destruction shaped the chemistry of the oceans and atmosphere, influencing the course of evolution. Each supercontinent was both an ending and a beginning, a rearrangement of life and land that reset the stage for everything that came next. About 250 million years ago, nearly all land on Earth gathered into one colossal supercontinent, Pangaea. It stretched from pole to pole, a single vast expanse surrounded by the global ocean known as Panthalassa. The interior of Pangaea was harsh and dry, far from the moisture of the sea, while its coasts were lush with forests and reptilian life. For tens of millions of years, this united world endured until pressure built deep beneath its crust. Cracks formed, magma surged upward, and the land began to split apart. The Atlantic Ocean was born, pushing the continents toward the positions we recognize today. Fossils of identical plants and animals found on distant continents are echoes of that ancient unity. Pangaea's breakup shaped modern geography and set the stage for the rise of new species, climates, and ecosystems. It was not the first supercontinent, nor will it be the last, only one chapter in an ongoing story of planetary motion. Even now, the next supercontinent may already be forming beneath the Pacific Ocean. The tectonic plates that shape our planet are still shifting, powered by the slow churning of the mantle below. In 200 or 300 million years, the continents may once again converge into a single mass. Some scientists predict that the Pacific Ocean will close as Asia and the Americas drift together to form Amasia, while others imagine the Atlantic closing instead, drawing Europe and the Americas toward each other. Though the details remain uncertain, the outcome is inevitable. The same hidden forces that once tore Pangaea apart are still at work, moving continents inch by inch. To imagine that distant future is to realize how temporary our maps truly are. The Earth is never still. It is a living engine of motion, always remaking itself. Even today, this movement continues in ways we can measure. Australia, for instance, is slowly drifting north toward Asia at a rate of several centimeters per year. Over millions of years, this steady motion will carry the continent thousands of kilometers until it collides with the islands of Southeast Asia, raising new mountain ranges and reshaping coastlines. Satellites track this journey with precision, watching as heat deep within the mantle propels massive plates like rafts across a molten sea. Though invisible to the human eye, these movements shape everything we know, shifting climates, altering ocean currents, and transforming ecosystems. Coral reefs bloom where land once stood, deserts creep closer to the tropics, and someday, the collision of continents will create new landscapes filled with mountains and valleys yet unborn. Africa, too, bears the marks of change. Deep within East Africa, the Great Rift stretches for thousands of kilometers, a vast scar in the crust where the continent is slowly tearing apart. Volcanic eruptions and earthquakes mark its path, revealing that a new ocean may one day flow through its center. Lakes such as Tanganyika and Malawi already fill the rift's deep valleys, early signs of the sea that will eventually flood in. The East African Rift is a visible reminder that continents are not rigid but alive, bending and stretching like skin over a living body. In tens of millions of years, the eastern portion of Africa, including Ethiopia, Kenya, and Tanzania, may drift away to form a new continent of its own. To stand on the rift's edges to witness the birth of a future world, a process so slow that it unfolds beyond the scale of human lifetimes, yet so powerful it will eventually reshape the face of the planet. Through all of this change, through ice ages and fire, through collision and erosion, the story of Earth remains one of transformation guided by time and pressure. The same forces that turn mud into stone, that grind mountains into dust, that raise continents from the sea, also govern the delicate balance of life that has flourished here for billions of years. From the first microbes that painted the oceans purple to the complex web of ecosystems that cover the planet today, everything is connected by a chain of cause and effect stretching back to the beginning. The rocks beneath our feet, the air in our lungs, the water that falls from the sky, all of it is part of a vast, intertwined story written by the Earth itself. And though we measure time in fleeting moments, the planet moves to a rhythm so slow, so deep, that to truly see it is to glimpse eternity. The continents we know will vanish, the oceans will shift, and mountains will rise again, but the Earth will continue its patient work, forever remaking itself, forever alive. Beneath our feet, an unseen drama unfolds, a slow, ceaseless story of fire, stone, and rebirth shaping the face of the world we know. The island of Iceland stands as one of Earth's most remarkable laboratories, perched directly atop a vast tear in the planet's crust known as the Mid-Atlantic Ridge. Here, two tectonic plates, the North American and Eurasian, are drifting apart, creating a scene where molten rock wells upward from deep within the mantle. As it breaches the surface, it cools and solidifies into new land, adding layer upon layer to the island's rugged terrain. This makes Iceland a living experiment of planetary creation, a rare place where scientists can witness the mechanics of plate tectonics in real time. It is a crossroads of fire and ice, where glaciers rest beside active volcanoes, where hot springs and geysers mark the breathing points of the Earth, and where every eruption is both a reminder and a renewal. The island exists in a perpetual state of construction, balanced between the frozen North Atlantic and the molten depths below, a dynamic landscape forever rewriting itself. Across the world, another chain of fire tells a similar but distinct story: the Hawaiian Islands. Rising from the vast Pacific Ocean, they are born not from the meeting of plates but from a stationary plume of magma, a hot spot that punches through the crust as the Pacific plate slowly glides northwestward. Each eruption forms a new island, which then drifts away as another begins to rise in its place. Over millions of years, this process has built a dotted trail of volcanic peaks stretching thousands of kilometers across the seafloor. The youngest island, Hawaii, still glows with active lava flows, its molten rivers carving paths that cool into black basalt, while the oldest islands, now worn down into low atolls, sit far to the northwest, eroded remnants of their fiery birth. This living timeline allows scientists to trace the movement of the Pacific Plate and understand the restless motion of the crust above a deep, unchanging source of heat. Each island in the chain is a geological diary entry, recording a moment in Earth's ongoing story of fire and creation. On another continent, beneath the forests and geysers of Yellowstone National Park, lies one of the most immense volcanic systems on the planet. Beneath the calm lakes and pine forests sleeps a vast chamber of magma, stretching for dozens of kilometers beneath the crust. This subterranean ocean of molten rock powers the park's famous geysers and hot springs, surface whispers of the inferno below. Though Yellowstone is tranquil today, its past eruptions have reshaped entire continents, scattering ash across North America and altering global climates. Scientists constantly monitor the region, mapping the magma chambers and measuring the Earth's subtle breathing, its uplift, its tremors, its heat. Yellowstone is a paradox, a place of serene beauty that conceals unimaginable force. It stands as a window into the planet's fiery heart, reminding us that even the most peaceful landscapes can rest upon hidden storms. When volcanoes reach their most powerful state, they become what scientists call supervolcanoes, forces capable of altering the planet's climate for centuries. While ordinary eruptions might affect local weather for a few seasons, a supervolcano can plunge the entire world into a volcanic winter. These colossal explosions eject thousands of cubic kilometers of ash and gas into the sky, blocking sunlight and lowering global temperatures. Evidence of such cataclysms lies in the geological records of Yellowstone in the United States, Toba in Indonesia, and Taupo in New Zealand. The aftermath of these eruptions echoes across millennia, ash settling across continents, ecosystems collapsing, species vanishing, and the climate resetting itself. Yet from such destruction often comes renewal. In the grand rhythm of the Earth, these eruptions are not just moments of chaos but cycles of creation, recycling minerals, reshaping landscapes, and opening new paths for life to evolve. Around 74,000 years ago, the planet experienced one of the most powerful volcanic events in known history, the eruption of Lake Toba in Indonesia. In a single, apocalyptic moment, more than 2,000 cubic kilometers of magma were expelled, leaving behind a vast caldera nearly 100 kilometers wide, now filled by the tranquil waters of Lake Toba. The skies darkened, sunlight dimmed, and global temperatures fell. Fine ash rained across continents, and the planet entered a temporary volcanic winter. Some scientists suggest that this event may have even influenced the course of early human evolution, creating population bottlenecks and migration shifts. Today, the lake appears serene, But beneath its quiet surface lies one of Earth's deepest scars, a sleeping titan whose fury once reshaped the world. Even smaller eruptions leave lasting imprints on our planet's atmosphere. Fine volcanic ash, light enough to drift in the upper layers of the sky, can circle the globe for years. Particles from eruptions like Mount Pinatubo in the Philippines or Krakatoa in Indonesia have been detected long after the lava cooled, carried by global winds that wrap the Earth in a veil of dust. These airborne fragments scatter sunlight, creating brilliant red sunsets and subtly cooling the planet. Artists throughout history have captured these volcanic sunsets, fiery skies painted by the echoes of explosions thousands of miles away. Layers of ancient ash have been found preserved in glaciers and ocean sediments, each one a frozen memory of an eruption that changed the air we breathe. Even now, microscopic particles from ancient eruptions drift above us, proof that the planet's atmosphere remembers everything. In a few rare volcanic craters around the world, the fire of Earth burns constantly and visibly. Lava lakes, such as those in Erode in Ethiopia or Kilauea in Hawaii, remain molten for decades, their surfaces churning like liquid metal. These lakes never fully cool because they are continuously fed by magma from deep below. The balance between heat input and loss is so perfect that they exist in a near-permanent state of motion, crusting over, cracking open, glowing, and reforming. To gaze upon one at night is to witness a window into the planet's core, a pool of living flame breathing in slow rhythm beneath a canopy of stars. For scientists, these natural furnaces are invaluable laboratories. By studying their gases, temperatures, and chemical makeup, researchers can learn about the processes that shape all volcanic activity. To the rest of us, they are mesmerizing reminders that the Earth is still alive, still young, still burning beneath its thin crust of stone and soil. Sometimes, this fire meets the sky in a display of astonishing power. When volcanoes erupt, the collision of ash particles inside the eruptive plume generates immense static electricity. These electrical discharges create volcanic lightning, forks of light crackling through black columns of ash. Unlike ordinary thunderstorms, volcanic lightning is born purely from rock and heat. The result is a sight both terrifying and beautiful: mountains wreathed in smoke and fire, skies split by blinding flashes that last only a heartbeat. Scientists study these lightning storms to measure the strength of eruptions, since more violent explosions tend to generate more electrical activity. But to witness one firsthand is to see nature's raw forces collide: solid, liquid, gas, and electricity converging in a storm of creation and destruction. In colder regions, another kind of volcanic drama unfolds: when fire meets ice. Beneath glaciers in places like Iceland, heat and ice collide with explosive consequences. When magma rises beneath a thick glacier, it melts immense quantities of water in seconds, creating vast steam explosions that can burst through the ice in violent floods known as Jokulhaups. These glacial eruptions carve new valleys, release clouds of ash, and reshape entire landscapes in hours. The hidden volcanoes of Iceland, sleeping under ice caps, often awaken without warning, their eruptions sending torrents of meltwater rushing to the sea. It is one of the most powerful demonstrations of nature's duality: cold and heat locked in eternal tension, each shaping the other. Beneath all this movement and fury lies a deeper truth: our planet is alive. It breathes through its vents, sighs through its geysers, and renews itself through its eruptions. From the birth of islands to the sculpting of continents, from the glowing lava lakes to the whispering ash in the stratosphere, Earth's fire is a constant companion to life. It destroys and creates, ending one world only to make room for another. The ground beneath us, though it seems still, is never at rest. It is the living skin of a planet that has never stopped dreaming itself into being. Beneath the Earth's surface, a constant dialogue between fire, water, air, and stone continues to sculpt the planet's body in ways both grand and invisible. When volcanic eruptions occur beneath glaciers, they create extraordinary formations called tuyas, flat-topped, steep-sided mountains that rise where fire once met ice. These strange landforms, found in regions like Iceland and British Columbia, stand as monuments to the union of opposites, a partnership between heat and cold that has existed since Earth's earliest days. Each eruption beneath this sheet of ice is an experiment in transformation, carving new ridges and plateaus where molten rock once met freezing water, proving that the natural world thrives on contrasts. Even in this harsh meeting of elements, creation triumphs over destruction, as glaciers and volcanoes together write new chapters in the geological history of our planet. Sometimes, the same fiery forces that built mountains also give birth to entire islands in the middle of the sea. Submarine volcanoes, hidden deep beneath the ocean's surface, occasionally erupt with such energy that they push new land up from the seafloor, forming islands where none existed before. In recent centuries, eruptions near Iceland, Japan, and Tonga have birthed newborn islands that steamed under the sun as they cooled. Some of these ephemeral creations disappear within years, claimed again by the ocean's waves, while others stabilize and harden, eventually supporting birds, plants, and even human life. Watching a new island rise is to witness the ancient process that once built continents, a reminder that Earth remains a living planet still engaged in its endless work of renewal. The moment life touches such places, when a seed takes root in fresh volcanic soil or a seabird nests on the cooling rock, it begins the slow transformation from barren lava to thriving ecosystem. The planet, ever patient, continues to build, break, and begin again. Yet not all of Earth's hidden power burns with fire. Some of it lies in stillness, waiting in the depths of lakes and caverns. In certain deep lakes of Africa, immense amounts of carbon dioxide gas accumulate over centuries, seeping from volcanic vents below the lakebed and dissolving invisibly into the water, like carbonation in a giant natural soda bottle. Under stable conditions, the gas remains trapped, but when temperature or pressure suddenly shifts, the result can be catastrophic. In 1986, Lake Nyos in Cameroon released a massive cloud of carbon dioxide that swept through nearby valleys, silently suffocating people and animals alike. This phenomenon, called a limnic eruption, revealed how even tranquil waters can conceal immense power. Today, scientists monitor such lakes and use pipes to release gas slowly before it reaches dangerous levels, preventing future disasters. These rare events show that the boundary between life and danger on our planet is often invisible and delicate. Beneath our cities, another quiet threat lurks: the mysterious collapse of the ground itself. Sinkholes form when underground layers of limestone or salt dissolve in groundwater, leaving behind hidden voids that can suddenly give way. Without warning, the earth can drop open, swallowing cars, trees, and entire buildings. Heavy rain, leaking pipes, or the weight of construction can accelerate these collapses. Some sinkholes are small, a few meters wide, while others stretch hundreds of meters across, forming vast pits that alter landscapes overnight. Scientists now use radar and sensors to map vulnerable regions and detect hollow spaces before disaster strikes. But the phenomenon remains a humbling reminder that what feels like solid ground is often temporary. These sudden collapses are part of a natural cycle in which water, ever patient, reshapes rock from beneath, dissolving the foundations of mountains and cities alike. This same slow chemistry of water and stone creates one of Earth's most magical landscapes, karst terrain, where rivers flow invisibly underground. In regions rich in limestone or dolomite, rainwater seeps downward, carving vast networks of tunnels and caves that can stretch for hundreds of kilometers. The land above often sinks in places, forming sinkholes, ridges, and valleys typical of karst formations. A stream that vanishes into a cave entrance may reappear miles away as a crystal-clear spring. Entire ecosystems have evolved in these lightless waterways: blind fish, translucent insects, and strange species that live in total darkness, relying on the faint nutrients carried by water. Karst landscapes are not just geological wonders, they are vital to life, providing drinking water for millions of people around the world. Yet, their hidden beauty also makes them fragile, easily polluted by surface waste or chemicals. Exploring a karst cave is like entering the planet's circulatory system, where water and stone whisper to one another, shaping and reshaping the earth drop by drop in a conversation millions of years long. Deep inside these caves, the slow dance of water continues to create wonders of breathtaking delicacy: stalactites, stalagmites, and towering stone pillars that seem to hold the sky underground. As water drips from the cave ceiling, it leaves behind a tiny ring of calcium carbonate, a crystal trace that grows downward over centuries into a stalactite. When each droplet falls to the floor, it deposits more mineral there, forming a stalagmite that rises to meet its counterpart. Over millennia, these features can join to form columns and pillars, sculpted entirely by patience and persistence. Their growth is imperceptible to the human eye, mere millimeters per century, yet over time they fill entire caverns with forests of stone. Lantern light reveals their delicate textures, rippling like frozen waterfalls, recording each change in water chemistry, temperature, and time. These mineral sculptures are living archives of Earth's climate, preserving records of droughts, floods, and shifts in rainfall patterns long before humans kept records. Each layer tells a story of ancient weather, locked in stone. Inside such caves, time itself seems to slow, reduced to the rhythm of drops falling in the dark. Here, beauty is born not from speed or violence, but from the persistence of quiet motion, a reminder that even in stillness, the planet never ceases to create. Some vast cave systems even have their own miniature climates. Deep underground, where sunlight never reaches, air circulates in complex patterns, creating microclimates with distinct humidity, temperature, and air currents. Warm air rising from deeper passages can meet cooler air near the surface, producing fog and mist that drift like clouds through stone chambers. Some caves breathe in rhythm with the seasons, exhaling warm air in winter and inhaling cool air in summer. As the air moves, it carries moisture that condenses on the walls, dripping gently to sustain both mineral formations and tiny subterranean life. To stand inside such a space is to feel the earth itself inhale, alive with slow, rhythmic motion. These enclosed worlds preserve fossils, artifacts, and even unique species found nowhere else on the planet. Within their stone lungs, one senses that the earth is not a dead mass of rock, but a living body with breath and pulse. Perhaps nowhere is this more evident than in Mammoth Cave in Kentucky, the largest known cave system on Earth. Stretching more than 400 miles beneath rolling hills, it is a labyrinth of passages, chambers, and underground rivers carved over millions of years by water-dissolving limestone. Even today, explorers continue to find new tunnels, adding to the world's longest-known subterranean map. Walking through Mammoth Cave is an encounter with the immensity of geological time. The silence is so deep it hums. The air remains cool and steady, untouched by the weather above. Here, one can grasp the true scale of nature's patience, how rivers, drop by drop, sculpted a cathedral of stone capable of swallowing entire cities. Mammoth Cave stands as both a geological wonder and a chronicle of time, an eternal record of water's persistence against rock. Each twist in its tunnels is a signature of the planet's quiet artistry, a masterpiece created not in years or centuries, but in eons. These subterranean realms remind us that the earth we walk upon is layered, breathing, and always in motion, from the fiery peaks of volcanoes to the hidden rivers of stone beneath our feet. Together, these processes form a vast, interconnected system of creation and renewal, a living engine that transforms the planet from within. Fire and ice, water and stone, light and shadow, all are partners in the slow, unending act of shaping the world. Whether in the birth of a new island rising from the sea, the patient growth of a stalactite in the dark, or the sudden collapse of a sinkhole swallowing the surface, the same story unfolds. Earth is alive. It moves, it breathes, it changes. Every tremor, every drip, every gust of air underground is a reminder that the planet is not finished with its work. It continues, moment by moment, to build and rebuild itself, an artist sculpting endlessly from the materials of its own body. When a massive earthquake shifts the distribution of Earth's mass, the very rhythm of the planet subtly changes, altering the length of the day by fractions of a second. These changes are imperceptible to us yet measurable by the sensitive instruments scientists use to track time and motion. Much like a spinning skater who pulls in their arms to rotate faster, Earth's moment of inertia adjusts when huge slabs of crust move. The 2004 Sumatra earthquake, one of the most powerful ever recorded, shortened the day by microseconds and even nudged the planet's poles slightly, reminding us that even something as seemingly fixed as time can be influenced by the deep convulsions of stone and gravity. Each quake is not merely a surface event but a planetary one, echoing through the Earth's entire body, resonating faintly in the background hum of our rotating world. The shock waves unleashed by massive quakes travel around the globe, circling it multiple times before fading. When such a quake strikes, the immense energy released radiates outward in waves that race through rock and mantle like sound through a bell, and seismographs on the opposite side of the world can still record their passing. These vibrations allow scientists to map Earth's internal structure, tracing how waves bend, reflect, and slow as they pass through layers of differing density and composition. Through such data, the hidden architecture of the deep Earth reveals itself: solid inner core, molten outer core, flowing mantle, and brittle crust, all engaged in an ongoing conversation of pressure and heat. Every great quake temporarily transforms the entire planet into a single vibrating instrument, humming faintly with its own heartbeat. The energy released during these colossal ruptures is staggering, often equivalent to millions of tons of TNT detonating in an instant. The shaking we feel on the surface represents only a fraction of this energy. Most of it plunges deep into the crust, forcing vast slabs of rock to move like titanic puzzle pieces. The modern moment magnitude scale was developed to measure these immense forces more accurately than earlier systems like the Richter scale. During the 2011 Tohoku earthquake in Japan, the energy released was so enormous that it shifted the seafloor several meters and altered Earth's rotation, just as earlier quakes had done. Such events demonstrate the scale of energy Earth constantly stores and releases, a slow, powerful rhythm that over millions of years shapes continents, raises mountains, and deepens oceans. Yet not all motion beneath our feet is sudden or violent. Deep underground, where heat and pressure rise to unimaginable levels, even solid rock can behave like a slow-flowing substance. Though it feels rigid and unyielding in our hands, under immense pressure and over vast timescales, rock deforms plastically, folding and flowing like an extremely thick liquid. This slow movement, called ductile flow, allows entire mountain ranges to rise, bend, and evolve. The mantle beneath the crust moves in a similar way, its slow convection currents driving the drift of continents across the globe. In laboratories, scientists have recreated this process by compressing and heating rock samples, watching them bend rather than break, revealing that time itself can change how matter behaves. The strength of stone lies not just in its hardness but in its ability to yield and endure, reshaping itself to survive the forces that act upon it. The rocks that form deep in Earth's interior, called metamorphic rocks, carry within them the memory of these pressures and transformations. When buried beneath layers of crust, ordinary rocks are subjected to such heat and compression that their very minerals reorganize, creating entirely new structures without melting completely. This process gives rise to stones like gneiss, which once was granite, marble, which began as limestone, and slate, which was once shale or mudstone. Each metamorphic rock is a geological diary, preserving evidence of the temperatures, pressures, and chemical changes that shaped it. Geologists read these textures and mineral alignments like pages in a book, reconstructing the history of ancient mountain-building events and the tectonic forces that forged them. The patterns in these rocks often reveal the directions of stress and flow, showing how crustal plates collided, folded, and uplifted through deep time. When erosion and uplift eventually expose these stones at the surface, we glimpse the planet's inner history frozen in crystalline form, a story of pressure, transformation, and endurance written in mineral veins and glittering grains. Consider slate. Once nothing more than soft mud lying undisturbed on a seabed, it slowly compacted under the weight of new sediments piling above. Over millions of years, this mud was pressed so tightly that its clay minerals aligned into fine, parallel layers, hardening into a rock smooth enough to split into perfect tiles. What was once loose sediment became a material used to roof homes, line pathways, and build walls, a transformation from softness to strength through patience and pressure. Hold a piece of slate to the light, and you can still see the faint sheen of its compressed minerals, echoes of clay that once drifted lazily across an ancient ocean floor. It is a quiet testament to how the softest materials can, through time and endurance, become among the most enduring. Marble tells another chapter of transformation. Long before it gleamed in temples, sculptures, and cathedrals, It was simple limestone made of shells and skeletons of marine creatures that settled on ancient seafloors. As these layers sank deeper into Earth's crust, they met heat and pressure that caused the calcite crystals within to grow, erasing visible fossils and transforming the stone into smooth, interlocking grains. Trace minerals, iron, serpentine, graphite, added subtle hues of red, green, or gray, and when polished, these minerals reflected light in a way that made marble appear almost luminous. Ancient artisans saw in this glow the essence of life captured in stone, unaware that the radiance came from the compressed remnants of long-vanished oceans. Each polished slab of marble we see today is a piece of geological memory, born from the ocean's floor and refined by the patient hand of time. Gemstones, too, are born from Earth's hidden processes, their brilliance forged under the most extreme conditions of temperature, pressure, and chemistry. Deep within the crust, atoms arrange themselves into crystalline perfection, forming diamonds under crushing weight hundreds of kilometers down, or emeralds in veins where mineral-rich fluids flow between cracks in rock. Rubies, sapphires, quartz, and topaz, all are children of rare coincidences in the planet's chemistry and heat. Their rarity is not only what makes them precious but also what makes them storytellers of specific geological environments. Each gem, when held to the light, offers a glimpse into the ordered beauty hidden in Earth's chaos, a structure of atoms locked into harmony through unimaginable forces. A diamond is carbon transformed by pressure, an emerald, the offspring of beryl and trace chromium, a sapphire or ruby, different shades of the same mineral born of different impurities. In pure form, corundum, the mineral behind both rubies and sapphires, is colorless. Introduce a hint of chromium, and it glows red as ruby. Let iron and titanium seep in, and it becomes the deep blue of sapphire. Small changes at the atomic level can transform light itself, creating the hues that humans have treasured for millennia. These gems travel through volcanoes, rivers, and erosion, from deep within the mantle to the surface, carrying with them messages from the depths. To gaze into one is to peer into time, to witness the frozen harmony of Earth's inner artistry. Together, earthquakes, rocks, and gemstones tell the same grand story of transformation. The planet is not still but alive, breathing, shifting, and renewing itself through cycles of destruction and creation. Every tremor that shakes the crust, every crystal that grows in darkness, every mountain that rises or erodes away, all are expressions of the same relentless creativity. Earth's beauty is built from pressure, its stability from motion, and its history from constant change. The mountains and stones we see today are only temporary forms in a much longer process, part of a living planet that continues to evolve. Beneath the surface, the same deep movements that shorten days and ripple through oceans also craft the quiet splendor of marble and the brilliance of diamonds. From the soft murmur of clay turning to slate to the violent roar of continents colliding, the story of Earth is one of eternal transformation, a masterpiece painted not in color, but in time, pressure, and the fact that two of the world's most prized stones, rubies and sapphires, originate from the same mineral, corundum, is a reminder of how small atomic variations can yield spectacular beauty. Each color a gemstone displays is like a fingerprint of chemistry, proof that nature's artistry begins in the invisible dance of elements deep within the earth. Emeralds, among the most coveted and mysterious of all gems, form only under extraordinarily rare geological circumstances. They require the perfect meeting of two very different environments, silica-rich rocks and beryllium-bearing fluids, conditions that seldom coexist. When they do, they give rise to the mineral beryl, which, when infused with traces of chromium or vanadium, takes on the deep green hue of emerald. These conditions are found mainly in mountain ranges forged by tectonic collisions, where immense pressure and heat mix ingredients that rarely meet. Each emerald, therefore, embodies a story of improbable chemistry and geological tension, its shimmering green facets carrying within them the very forces that created it. Most emeralds bear tiny fractures and inclusions, called jardin, meaning garden, that mark their natural birth. These imperfections are not flaws but signatures of authenticity, evidence that the stone is truly of the earth and not the product of laboratory artifice. To hold an emerald is to hold a miracle of chance, pressure, and time, a gem that captures the balance between fragility and strength, chaos and order, born in the slow forge of mountains. Opal, by contrast, tells a softer, more fluid story. Unlike most gemstones, it is not crystalline. It forms when ancient groundwater rich in dissolved silica seeps through cracks in rock. Over time, as the water evaporates, it leaves behind microscopic silica spheres that arrange themselves in delicate layers. These layers scatter light in a way that produces opal's otherworldly rainbow shimmer, known as play of color. Every opal is a mosaic of light trapped in stone, a memory of vanished rain and long-dried seas. Many opal deposits formed in regions that were once underwater millions of years ago, arid landscapes that have since turned to desert. In Australia, where some of the world's finest opals are found, the stones record the transformation of ancient inland seas into plains of fire-colored earth. Under magnification, an opal reveals a universe of order hidden within a parent case. A symphony of tiny spheres aligned so precisely that they bend and split light like a prism. Each one is a relic of evaporated water, sunlight, and geological patience, a piece of rain immortalized in stone. While gemstones form deep within the earth, some of the most extraordinary rocks come from beyond it. Meteorites, fragments of stone and metal that fall from space, carry within them the oldest stories in our solar system. These alien visitors are time capsules, forged billions of years ago from the same dust and gas that once surrounded the newborn sun. Many contain minerals that have remained unchanged since that cosmic dawn, preserving a record of the chemical processes that shaped planets. Some even hold organic compounds, hinting that the ingredients for life may have been scattered through space long before Earth was formed. To touch a meteorite is to touch something older than the world itself, a survivor of the universe's earliest days, carrying within it the memory of stars, explosions, and creation. Within some meteorites, scientists have discovered microscopic grains known as presolar dust, particles that predate the solar system entirely. These grains were born in the outer layers of dying stars and carried into space by stellar winds. Over billions of years, they drifted through the galaxy, mingling with interstellar clouds until they became part of the material that coalesced into our sun and planets. Each grain bears an isotopic signature unlike anything naturally found on Earth, a fingerprint of its extraterrestrial origin. To find such particles locked inside a meteorite is to find literal stardust, ancient matter unaltered since before the birth of our world. They are whispers from before time as we know it began, echoes of supernovae and red giants that gave their dying breath to forge the elements from which everything, including us, is made. The Earth itself, then, is not just a planet but a mosaic of star remnants, assembled from the ashes of countless suns. Our moon tells part of this same cosmic story. When astronauts brought back lunar rocks during the Apollo missions, they did more than reveal the moon's geology. They provided clues about Earth's own beginnings. The isotopic composition of lunar rocks is nearly identical to that of Earth's mantle, suggesting that the moon formed from debris left behind after a colossal collision between the young Earth and a Mars-sized body. That impact ejected molten material into orbit, where it eventually coalesced into the moon. Studying these rocks has allowed scientists to estimate when Earth's crust first solidified, around 4.5 billion years ago. The moon's surface, pitted and scarred by billions of years of impacts, preserves a record of cosmic bombardment lost on our weathered and tectonically active Earth. Every moon rock brought home is a time capsule of that shared origin, written in the language of dust, impact, and fire. On Earth, the oldest minerals ever discovered are tiny zircons found in the ancient rocks of Western Australia. These microscopic crystals, dating back more than 4 billion years, formed just after the planet itself. Each zircon contains traces of uranium that have slowly decayed into lead over billions of years, allowing scientists to measure their age with extraordinary accuracy. Their chemical composition also provides evidence that liquid water existed on Earth's surface when they formed, suggesting that oceans may have appeared astonishingly early, perhaps within 200 million years of the planet's birth. Before this discovery, scientists believed the young Earth remained a molten inferno for hundreds of millions of years. But the zircons told a gentler story, one of rapid cooling, condensing clouds, and the first rain falling upon newly solid rock. These crystals are not just minerals, they are the oldest witnesses of Earth's transformation from fire to water, from chaos to balance. Within each one lies a microcosm of the planet's earliest environment, a record of the moment Earth became capable of sustaining life. The story of Earth's crust continues through epochs of both calm and catastrophe. Long after its surface solidified, the planet still pulsed with volcanic fury. Throughout deep time, vast volcanic events known as flood basalt eruptions blanketed entire regions and rivers of molten rock. These eruptions, sometimes lasting millions of years, formed enormous plateaus thousands of meters thick and stretching across continents. The Deccan Traps in India and the Siberian Traps in Russia stand as monumental remnants of these fiery cataclysms. Such eruptions released massive quantities of carbon dioxide, sulfur dioxide, and other gases into the atmosphere, altering the planet's climate and triggering environmental chaos. The skies darkened with ash, oceans acidified, and ecosystems collapsed. Yet, when the fires died and the rock cooled, the same basalt that had destroyed became the foundation of fertile soils, nourishing new forests and shaping future landscapes. The Earth, in its endless cycle of destruction and renewal, turned devastation into creation. The greatest of these volcanic outpourings, the Siberian Traps, coincided with the most devastating extinction event in Earth's history, about 250 million years ago. Known as the Great Dying, it eradicated nearly all marine species and most land animals. For thousands of years, volcanic gases choked the atmosphere, causing global warming, acid rain, and oxygen-depleted oceans. Yet even after this unimaginable collapse, life returned. New species evolved, adapted, and diversified, filling the empty niches left behind. From ruin, resilience arose. These cycles of death and rebirth are woven into Earth's history, shaping both its surface and the life that clings to it. Through gemstones, meteorites, zircons, and volcanoes, we see that the story of our planet, and indeed, of the universe, is one of transformation. Beauty, whether in the green fire of an emerald, the kaleidoscope of an opal, or the shimmer of a zircon, is the product of pressure, patience, and time. Every stone, every grain of dust, carries a memory, of stars that died, of seas that vanished, of mountains that rose and fell. The Earth's calm face hides a restless heart, forever changing, forever creating. From the cosmic dust that formed the first rocks to the glowing gems that capture light within their depths, every mineral is a fragment of an infinite narrative, the story of how matter becomes memory, and how, through pressure and time, even chaos can crystallize into beauty. Earth's long story is one of unending transformation, where destruction and creation intertwine in an eternal cycle that shapes everything from continents to the tiniest grains of sand. Even the most devastating events, massive volcanic eruptions, violent earthquakes, and global extinctions, become foundations for what follows, reminders that renewal is written in the same language as ruin. In every extinction lies the seed of evolution, hidden within the ashes of catastrophe, waiting for the moment to bloom anew. Volcanic ash, for instance, still rests quietly within the world's soils, preserving the memory of ancient eruptions that once darkened skies and reshaped landscapes. Each thin layer buried in sediment is a timestamp of fiery history, its unique chemical composition allowing scientists to trace it back to the exact volcano that birthed it. Farmers unknowingly plowed this history into their fields, enriching the earth with minerals forged in fire. The same ash that once choked the air now feeds crops, vines, and forests, completing a circle of transformation where destruction gives birth to fertility, and the residue of fire becomes the cradle of life. Across regions like Italy, Iceland, and Japan, entire civilizations have flourished upon soils born of volcanoes, proving that creation often emerges most vividly from chaos. Long before our world took its present shape, the land masses we now call continents were joined in a colossal embrace, a single supercontinent known as Pangaea. Around 200 million years ago, deep beneath its surface, immense forces began to pull it apart. Fissures opened, magma rose, and the planet itself began to stretch, giving birth to a rift that would one day become the Atlantic Ocean. What began as a fracture between two plates slowly widened as molten rock welled up from Earth's mantle, solidifying into new crust that pushed the continents farther apart. This continuous process of seafloor spreading created the Mid-Atlantic Ridge, a vast, submerged mountain range where new crust still forms today. In its earliest days, the Atlantic was little more than a long, water-filled valley, much like the Great Rift Valley in Africa today. Over millions of years, this wound in the planet's surface deepened and widened, transforming into an oceanic expanse teeming with life. Even now, magma rising from the mantle pushes the seafloor outward by a few centimeters each year, imperceptible yet unstoppable, as Africa and the Americas drift slowly away from each other. Beneath the waves, this movement leaves behind clues written in the language of magnetism. As molten rock cools along the ridge, tiny magnetic minerals within it align with Earth's magnetic field, freezing in place like compass needles pointing north. Because the magnetic field occasionally reverses, north becoming south and vice versa, these minerals form symmetrical stripes of alternating polarity on either side of the ridge. When scientists first measured these patterns, they confirmed what had once seemed impossible. The seafloor itself was spreading, carrying continents across the surface of the planet in a vast, slow dance known as plate tectonics. Each stripe of magnetized rock is a chapter in this story, marking moments when the invisible force of Earth's magnetic field flipped, reminding us that even the unseen energies protecting our world are dynamic and ever-changing. Along these mid-ocean ridges, another wonder unfolds in the perpetual darkness: hydrothermal vents, sometimes called black smokers, where seawater seeps deep into the crust through cracks and fissures. As the water descends, it encounters molten rock, heating to hundreds of degrees before rising again, rich with dissolved metals and minerals. When it bursts back into the frigid ocean, the sudden cooling causes these materials to precipitate, forming dark, billowing plumes that look like smoke. Around these vents, chimneys of iron, sulfur, and other minerals grow upward, layer by layer, sometimes reaching heights taller than houses. These shimmering towers, glowing faintly in the deep, are not lifeless structures but the beating hearts of entire ecosystems. Far from sunlight, life gathers here, thriving on energy drawn not from the sky but from the chemistry of the earth itself. Bacteria use chemosynthesis to convert sulfur and methane into food, forming the base of a strange, independent web of life. Giant tubeworms, clams, shrimp, and ghostly fish cluster around these vents, surviving in temperatures that swing from near freezing to over 300 degrees Celsius within a few meters. Before their discovery in the 1970s, scientists believed life could not exist without sunlight. These deep-sea colonies shattered that assumption, revealing that as long as there is energy, whether from the sun or from the planet's molten heart, life will find a way. The existence of these ecosystems has led researchers to speculate that similar life forms might exist on icy moons like Europa and Enceladus, where hidden oceans may host their own vent-like systems. The vents on our ocean floors thus serve as blueprints for life beyond Earth, showing that even in the darkest, most extreme environments, biology and geology are bound in partnership. Over time, minerals from the vent fluids accumulate into towering chimneys, continuously building and collapsing, creating landscapes of shimmering metal deep beneath the waves. These formations contain concentrated ores, iron, copper, zinc, and gold, the same resources humans mine on land, though few have ever seen them firsthand. The vents themselves pulse with energy, releasing mineral-rich clouds that glisten in the light of submersible lamps. Each structure is both delicate and durable, proof that even under unimaginable pressure and heat, Earth sculpts beauty. They are cathedrals of chemistry, hidden in the deep silence, thriving in a realm of perpetual night where no sunlight has ever touched. Above these subterranean worlds, Earth's magnetic field acts as an invisible shield, protecting life from cosmic radiation and solar winds. Generated by the movement of molten iron in the outer core, this field is anything but static. It flips, drifts, and pulses with time. Throughout Earth's history, the magnetic poles have reversed hundreds of times, swapping north and south in a slow, chaotic process that unfolds over thousands of years. Evidence of these flips is captured in volcanic rocks and oceanic crust, where iron-bearing minerals preserve the orientation of the magnetic field as they cooled. Though a reversal might cause compasses to point south and navigation systems to falter, life itself has persisted through every one without major harm. These reversals are simply part of the planet's natural rhythm, an outward sign of the restless motion in its molten heart. Even today, the magnetic poles are not fixed. The North Magnetic Pole, once located in Canada, is drifting rapidly towards Siberia, moving more than 30 kilometers each year. This migration results from subtle changes in the flow of liquid iron deep within the core. Satellites constantly monitor this motion to update navigation systems, mapping the shifting lines of magnetic force that encircle the globe. To most people, the wandering of the poles goes unnoticed, but for scientists, it is a vivid reminder that Earth is not a static sphere, it is a living, breathing planet whose very heart churns and evolves. The molten core beneath our feet is in constant motion, generating the magnetic heartbeat that guides compasses and shields our atmosphere from solar storms. Without this ever-changing field, our planet's surface would be bombarded by radiation, its skies stripped away. Through all these processes, volcanic fire, continental drift, seafloor spreading, magnetic reversals, and deep ocean chemistry, Earth demonstrates a single truth: creation and destruction are never separate forces but two sides of the same movement. The ash that once buried landscapes now nourishes them. The rifts that tore continents apart gave birth to oceans. The molten chaos beneath our feet sustains life in the coldest depths of the sea. Even the invisible energy that makes compasses turn is the product of turmoil in the planet's core. From the surface to the deepest mantle, every layer of Earth participates in an intricate cycle of renewal, proof that stability arises not from stillness but from constant motion. To walk upon this planet is to tread on billions of years of change, on ash turned to soil, lava turned to stone, and ocean crust still forming beneath the waves. Every grain of sand, every pebble, and every mineral carries the story of transformation. The Earth's calm present hides an untamed past and hints at a restless future, where mountains will rise and crumble, oceans will open and close, and magnetic poles will drift again. Yet through it all, life endures, adapting, thriving, and reshaping itself in harmony with the ceaseless rhythm of the planet's heart. The same heat that drives volcanoes also fuels deep-sea life. The same magnetic fields that shift and reverse protect all living things. And the same cycles of destruction that once wiped species from existence created the space for new forms to flourish. Earth, in all its restless beauty, is not merely a world we live upon, it is a vast, breathing organism, forever remaking itself, and us along with it. The moon is far more than a glowing orb in our night sky. It is the silent metronome that keeps the heartbeat of our planet steady. It stabilizes Earth's wobble, shaping long-term geology and the rhythm of life itself. Without its steadying influence, Earth's axial tilt could swing chaotically over time, shifting from nearly upright to deeply angled, creating wild climate transformations that would turn frozen poles into tropical forests, and then back into ice once more. Yet because of the moon's gravitational pull, Earth remains stable, its tilt held within a narrow range that allows for the predictable cycles of seasons, ocean currents, and ice ages. This delicate balance provides the consistency upon which ecosystems, evolution, and civilizations have all depended. Every tide, every rhythmic season, every steady pulse of wind and wave carries a silent echo of the moon's influence. For more than 4 billion years, it has guided the dance of our planet without a single misstep. The tides born from this pull do far more than rise and fall. They sculpt the face of the world. Each day, the ocean responds to the moon's gravity, lifting and lowering as if breathing with the cosmos. Over millennia, these movements carve coastlines, create estuaries, and widen bays. Sediments are carried and deposited, forming beaches, deltas, and barrier islands. The same slow rhythm erodes cliffs, feeds coral reefs, and nourishes entire marine ecosystems. In certain places, the tidal range exceeds 10 meters, creating vast intertidal zones that alternate between land and sea, hosting life uniquely adapted to both realms. These environments are nurseries for fish, breeding grounds for birds, and havens for countless invertebrates. The moon's gentle tug ensures that oceans circulate, distributing energy and nutrients across the globe. The shorelines we see today are not static. They are moving sculptures, shaped grain by the patient breath of the moon. Beneath the ocean's surface, coral reefs stand as living monuments to this geological dance. Each coral polyp, no larger than a fingernail, builds a limestone skeleton. Over generations, these tiny architects stack their structures toward the sunlight, forming immense reefs that can stretch for thousands of kilometers. The Great Barrier Reef, one of Earth's grandest natural wonders, spans more than 2,000 kilometers, visible even from space. It was built by living hands, millions of coral organisms working together, generation after generation. When old corals die, new ones grow atop their remains, creating a living cycle of construction and renewal. These reefs are not merely biological marvels. They are geological archives, recording ocean temperature and chemistry in their calcium layers. Even fossilized reefs found in deserts and mountains tell stories of ancient seas that once covered the continents. Some reefs alive today began growing tens of millions of years ago, their foundations laid down when dinosaurs still roamed the earth. As sea levels rose and fell, they climbed upward or migrated, always seeking the light. Their persistence reveals the planet's continuity through upheaval, a bridge of life and stone that outlasts mountains. Every reef is both delicate and eternal, a cathedral of color and calcium that breathes life into the sea. The world's deserts, though barren at first glance, are part of this same planetary conversation. Tiny grains of dust, born from eroded stone in places like the Sahara, rise into the atmosphere and travel thousands of kilometers across oceans. Winds carry them as silent messengers of minerals and nutrients, connecting the most distant ecosystems on Earth. Each year, hundreds of millions of tons of Saharan dust settle over the Amazon rainforest, delivering phosphorus that sustains its vast network of trees and plants. Without this mineral connection, the rainforest's fertility would fade as heavy tropical rains washed nutrients away. These airborne travelers create invisible bridges between continents. Deserts feed jungles, barren lands nurture abundance. From space, satellites capture these grand plumes as they shimmer across the Atlantic, a golden haze that nourishes life and ocean away. Each grain is a geological traveler, a fragment of ancient rock that left one landscape to sustain another, proving that even in stillness and desolation, the Earth finds ways to share its wealth. And within the stones of our planet lie older stories still, traces of cosmic birth. Hidden inside certain meteorites, and even within the oldest terrestrial rocks are microscopic grains of stardust, formed in the hearts of dying stars long before our solar system existed. These tiny specks are older than Earth itself, remnants of ancient supernovae that exploded billions of years ago. When scientists study them, they uncover isotopic signatures unlike anything found on our planet, proof that these grains were born in distant stellar furnaces. Each particle holds within it the record of a star's life and death, of elements forged in fire and scattered into the void. These are the seeds from which all worlds, including ours, were made. Every atom in our bodies, from the iron in our blood to the calcium in our bones, was once stardust. The gold and platinum we prize did not originate here either. During Earth's earliest formation, nearly all of its heavy metals sank into the molten core, leaving the crust depleted. The metals we now mine and mold were delivered later, during a rain of meteor impacts more than 4 billion years ago. Those celestial collisions scattered precious elements across the surface, enriching our planet with the treasures of the cosmos. Each vein of gold or platinum is the residue of that fiery inheritance. To hold a piece of gold is to touch the ashes of an ancient star, a fragment of cosmic memory transformed into earthly beauty. Over time, the scars of those impacts have faded. The Earth, ever patient, heals itself. Craters that once gaped wide and raw have softened under wind, water, and time. Sediment fills them, forests grow over them, and cities rise unknowingly atop their remains. Only when scientists look closely, using satellite imagery, magnetic surveys, and deep drilling, do the ancient wounds reveal themselves. Beneath layers of soil and stone lie shattered quartz, melted minerals, and rings of fractured crust that whisper of catastrophic origins. Across continents, from North America to Africa and Australia, geologists have found these buried scars, some billions of years old. Their near invisibility reminds us of the planet's resilience, its ability to smooth even the deepest wounds into quiet harmony. Yet these same impacts shaped the course of life itself. One colossal collision, striking Earth at just the right moment, may have triggered the rise of the dinosaurs by altering climates and clearing ecosystems. Another, millions of years later, ended their reign in a fiery instant, paving the way for mammals, and eventually humans, to emerge. The fingerprints of space remain imprinted upon our geology, written in the very bones of the world. From the moon's steady pull to the quiet fall of desert dust, from coral skeletons to stardust grains, the Earth is not a static place, it is alive with motion and memory. Every process, no matter how slow, contributes to a grand cycle of creation and renewal. Rocks weather and crumble into soil, soil nourishes life. Life dies and becomes rock again. Water flows, freezes, and evaporates, sculpting continents in its endless journey. Mountains rise and erode, oceans advance and retreat, stars are born and die, scattering the materials that will one day form new worlds. The same forces that shape the cosmos shape us. Our bones are made of calcium from ancient seas. Our breath is filled with oxygen released by microscopic life billions of years ago. Our existence depends on rhythms set in motion before Earth even formed. To look at the world through geological time is to see patience as the ultimate artist. Nothing is wasted, nothing truly ends. The moon's tides, coral reefs, desert dust, stardust, and the planet's quiet healing after impact, all these are threads in one vast tapestry of transformation. Over billions of years, energy flows through matter, turning chaos into balance and destruction into beauty. The world beneath our feet hums with memory of fire, ice, oceans, and stars. Every grain of sand, every ripple of tide, every stone beneath your hand is a fragment of the universe remembering itself. The Earth's calm today is the result of billions of years of motion and change, a delicate equilibrium born from violence and time. The tides still rise and fall, the reefs still grow, the deserts still send their dust into the air, and in the quiet between stars, new worlds are forming from the remains of the old. We are living within that cycle, temporary, fragile, and yet infinite in our connection to it. Around 200 million years ago, Earth was struck by a massive asteroid near what is now Canada, a cataclysmic event that coincided with the end Triassic extinction, forever altering the planet's evolutionary path. The impact unleashed unimaginable energy, enough to ignite wildfires that devoured entire continents and darkened the skies for years, shrouding the world in a thick, choking veil of dust. Volcanic eruptions soon followed, pouring molten rock across vast regions while releasing greenhouse gases that sent global temperatures soaring and plummeting in unpredictable swings. Countless reptile species succumbed to these harsh conditions, unable to adapt to the rapidly changing world, while other creatures, most notably the dinosaurs, rose to dominance, their physiology and resilience perfectly suited to the unstable new Earth. Though the crater from that ancient collision has long since been worn down by time and erosion, its scar still whispers through traces of molten rock and shocked quartz buried deep underground, a geological testament to a day when the world nearly ended. Events like this have reset the course of evolution again and again, wiping the slate clean, erasing entire lineages, and giving rise to entirely new ones. From chaos emerges renewal, and from the ashes of destruction, life begins anew. In that delicate balance between ruin and rebirth, the mighty reptiles of the Mesozoic era took control of Earth, shaping its ecosystems and future for more than 150 million years, until another rock from the sky sealed their fate. 66 million years ago, a 10-kilometer-wide asteroid slammed into what is now the Yucatan Peninsula in Mexico. The impact unleashed a force greater than billions of atomic bombs combined. Rock vaporized instantly, global wildfires roared across forests and plains, and a colossal plume of dust and soot wrapped the Earth in darkness. Sunlight vanished for years, temperatures plunged, and photosynthesis ceased. Without sunlight, plants withered, herbivores starved, and predators soon followed. More than 70% of Earth's species vanished, including the once mighty dinosaurs that had ruled land, sea, and air. Yet within that extinction lay the seed of another beginning, the rise of mammals, small survivors who would inherit the Earth and eventually give birth to humanity. The crater left behind, known as Chicxulub, remains hidden beneath layers of limestone, but deep within its rim lie unmistakable traces of intense pressure and unimaginable heat, preserved like a fossilized explosion frozen in time. It stands as one of Earth's most profound reminders that every end births a new beginning, that destruction and creation are two sides of the same cosmic coin. Across Earth's surface lie countless other scars of ancient collisions, though many remain invisible, buried beneath deserts, oceans, and layers of rock. Geologists detect these hidden craters not by sight but by listening to the whispers of gravity and magnetism, subtle, circular anomalies deep underground that reveal where cosmic forces once struck. Some craters are so ancient they date back billions of years, to an age when the young Earth was battered relentlessly by space debris, reshaping its crust and perhaps even delivering the water and organic molecules that made life possible. These invisible scars are the planet's first memories, the faint signatures of its chaotic youth. Though wind, rain, and plate tectonics have erased their outlines, the memory remains locked in the stone, a quiet record of a violent past. Every new discovery is a reminder that our calm, stable world is built upon the wreckage of cosmic catastrophe, and that the solid ground beneath us has been shaped by impacts, eruptions, and time itself. Yet even now, the Earth continues to grow, not through cataclysms, but through a gentle and constant rain of cosmic dust. Every day, hundreds of tons of tiny particles drift from space into our atmosphere, streaking briefly as meteors before settling unnoticed upon oceans and continents. Much of this interplanetary dust comes from comets and asteroids that shed fragments as they orbit the Sun, remnants of our solar system's earliest days. Scientists collecting samples in Antarctica and on rooftops around the world have found microscopic spheres glinting under microscopes, tiny metallic beads forged in the furnace of stars. Over billions of years, this quiet accumulation has slowly increased Earth's mass, grain by grain, linking our planet to the greater universe in a constant exchange of matter. The dust that falls upon us each night is a reminder that Earth is never isolated. It is a living part of a vast, breathing cosmos. Geology binds together all these threads, mountains, oceans, fossils, and living creatures, into a single, continuous story. The same immense forces that lift mountain ranges also drive the seas, shape continents, and create the conditions for life. The layers of rock beneath our feet are the pages of Earth's diary, recording every upheaval, every age of ice and fire. Fossils tell of vanished worlds, creatures that once swam, flew, and walked across landscapes long buried beneath newer layers of stone. Minerals reveal how deep, hidden processes within the earth sculpted the continents, while rivers and winds carry the memory of erosion, wearing mountains down into grains of sand. Over billions of years, the cycles of plate tectonics, volcanic activity, and weathering have woven together a seamless narrative, a living planet in perpetual transformation. Geology is the language of this story, written not in words but in strata, minerals, and fossils. It teaches us that the Earth is not merely old, but alive, breathing, moving, and remembering. Every pebble, cliff, and mountain holds a fragment of that memory. Within the grains of stone lie the chemical fingerprints of ancient seas, volcanic eruptions, glacial ages, and drifting continents. Radiometric dating acts as the clock of eternity, allowing us to measure the ages of rocks and trace the rhythm of deep time. Fossils and mineral veins tell stories of pressure, heat, drought, and flood, records of creation and decay layered one atop another. The solid ground beneath us, which feels so permanent, is in fact a momentary form of motion, a crust that is constantly forming, breaking, and reforming in endless cycles. To listen to the earth is to hear its quiet memory, the slow murmuring of stone, the pulse of magma deep below, and the whisper of wind sculpting new landscapes above. Even as we rest, the world beneath us moves. The ground turns beneath stars that once forged the minerals in our bones. Beneath the crust, molten rock flows in ceaseless convection, drifting continents like clouds across a molten sea. Mountains rise grain by grain, oceans widen slowly beyond memory, and deserts migrate under the breath of time. Change on this scale does not roar, it whispers. Every rock, every crystal, every grain of sand carries the echo of epochs older than life itself. Our own brief stories flicker like sparks within that vast continuum, yet they too are written in the same cosmic script. Somewhere deep inside the earth, pressure builds and stone transforms. Somewhere else, it erodes into dust that drifts across oceans to nourish life. Nothing is lost, everything becomes something new. As you imagine this slow, eternal rhythm, the pulse of the planet beneath you, let it quiet your thoughts and steady your breathing. The warmth of sand between your fingers, the crunch of gravel underfoot, the cool roughness of stone, all are pieces of the planet's endless transformation. The Earth does not merely host life, it is life, in motion. It remembers everything, every impact, every eruption, every breath. To lie upon it is to rest in the arms of time itself. So as you drift towards sleep, let your thoughts sink down through layers of soil and stone, to the molten heart below. Feel the deep, steady heartbeat of the world, ancient and eternal, holding you gently as it turns beneath the stars. You are part of that story too, one fleeting moment in the infinite memory of a planet that has never stopped dreaming, never stopped changing, never stopped creating itself anew. Sleep well, traveler of Earth, for even in rest you move with the planet's timeless rhythm, carried forever through the quiet dance of stone, sky, and stars.